Okay, welcome to day 3 of our presentation on the Plant and Equipment Wellness Way. Today is about bringing the whole thing together into a final package. There are some repeating of what we've covered already, but in a way that gels it together into an overall perspective. So I've talked about the foundational concepts in day 1 and the importance of understanding how these things interact across a life cycle situation. Day 2, we talked about the application of the tools and techniques and methods and processes of plant and equipment wellness, how to go from an analysis situation right through to an implementation, an application, and then a fix into place practice. Day 3 is really about understanding how to use these techniques and concepts to create reliability. I've already said reliability is something that we invent. We actually decide how much reliability we need and we create the processes to generate that reliability. So today we'll talk about that. The whole point, of course, is to minimise operating and business risk. We want to free up the money that's now being lost and put that money to good use for future growth of the company or profits as need to be used. Stress, of course, is the driver. Stress that fails the part, that fails the machine, that fails the business, that fails the company. We want to stop the stress that break the parts. So everything's been very much focused on how machines and equipment fail, and in particular how not to let them fail. It's a life cycle issue. Plant wellness uses the life cycle concepts. A lot of other methodologies in maintenance and reliability are about what's happening in the plant today and living with the troubles we have today and solving today's problems. Plant wellness will do that. There certainly can be done, but we're about the whole business life. And we want to use the right things and do the right things from the very beginning and understand what those right things are to be put into place. So we'll cover off both the life cycle risk issues and using the life cycle thinking to maximise operational profits by reducing operational risk. Then we'll finish off with about machinery risk reduction, talking about the economics of decisions. Which decisions do we do that pay back best for the company and give us maximum reliability? Because in the end, maintenance is an economic choice. It might be okay to let things break. It might be okay to allow the complete plant to blow up. It might be the cheapest thing to buy a whole brand new plant, then maintain it. But I wouldn't be able to say that until I modelled my financial options. So if you're a maintenance person and you're a maintenance manager in particular, you've got to be a financial manager too. You've got to have tools to financially model your 3 or 4 different choices across the life cycle period and see which one makes the most money for the company. Because breakdowns aren't necessarily bad. They're only bad if they are the crazy thing to do out of all the choices that you had available to you. Finally, we're going to touch on change management. These 3 days are about the plant and equipment wellness process, what it is, the way it works, how we use it. It is about 20% of the effort required to actually make the change in a company. We will come up with the plans, come up with strategies, come up with very good reasons, financial reasons to do the changes. But then the people in the workplace have to make that change. Management have to buy into it and drive the change, push that all the way through the company, get people to want to do this, to come on board with the future success of the company. So the hard 80% will be changing the mindsets, the culture, the habits that have been there and made the company that it currently is. So I want to touch a bit on change management, just to talk about what it is, to appreciate that plant and equipment wellness will also require cultural change in a company, and we want to provide a vehicle for that cultural change and be part of that cultural change and be with companies for the rest of their working life and help them get better and better and better. I don't want to simply go to a company and say, here's a pile of paper, turn my back and walk away. I want to work with them to take this to as far as they can take it. And I want to be a partner with these companies and yourselves as well, to partner your clients all the way to their success and to hopefully in the end your success as well. So yeah, change will be a necessary and it'll be the hardest part. But there are ways of doing this and doing it well, and we'll discuss a few of those when we get to that. This is, again, one slide trying to incorporate a lot of different concepts. The problem that companies have is their machines and equipment continue to fail. Many companies have tried many reliability improvement ideas. Root cause analysis, they bring in lean methodologies, they apply techniques that the world's best are using, and they never get to become the world's best. Doing all the things that are supposedly meant to get them there, but they don't get there. There is something still vitally missing for most companies. Some companies do go from being dogs to being world class, and it can be done. That's why I'm sure there are answers out there, but not every company can find those answers. So after many years, and certainly in my career of 30 years as an engineer and involved with maintenance and engineering, there are companies that have never progressed beyond being average and perhaps even less than average, no matter how hard and what they've done. So yeah, we still have machines failing even after 100 years of engineering knowledge and improvement, fully understanding what to do. Now, the physics of failure explains why things break and how to stop them breaking, yet that is not getting into companies. So companies, in my eyes, do not understand the total economics of loss. They don't know how much money they're actually losing because nobody sees the nebulous part of the life cycle impacts. They do not understand the science of failure, why things break, how they break their things, and what to do about that. They don't measure risk and probability of risk. They don't understand the odds. They're rolling dice, not understanding what the numbers that pop up mean to them. They do not see the life cycle failure causes. They do not realise that the decision made 20 years ago, the project guys in the capital group, actually causes today's breakdown. They don't see that 20-year picture. They do not view machines as a system of parts. One part in 100 fails, the whole machine goes down. Any one of those 100 parts fails, the whole machine goes down. The whole thing is a system. I have to have the system at high reliability. And that means every part of those 100 have to be even more reliable than its machine. They do not view production as a system, do not view their business as a system, do not view the life cycle as a system. They see snapshots of a week or two or a month or a year at a time, not the 30 or 40 or 50 year vision that is required to get maximum reliability. So plant and equipment wellness, its solutions are intended to provide money through achieving reliability. Reliability has to deliver money, and we want to prove the money's there first before we even go chasing it. We build a system-wide solution. System-wide as in production-wide, business-wide, life cycle-wide. We want to pick all that big picture stuff up and paint a very clear vision of the future and how good that's going to be. We want to remove risks to parts across the lifetime of that machine. So if that machine, that bearing in that machine is going to be there for 50 years, then we want to make sure that bearing does not fail for 50 years. Now, it might be changed out after so many years, but it will be a planned change. It won't be because it breaks down. We want to reduce the stress. We want to reduce the stress in parts to the very lowest levels possible by doing precision work, by being everywhere accurate and knowing what quality we have to achieve to get that low stress, to create lasting machine health, literally, wellness forevermore. We want to team up knowledge and skills. The dysfunctional structures that companies have that actually create silo thinking and create divisions between people, in fact create wars and fights and barriers between people in the same company, we want to cut those out. We want to bring the people that can solve problems together and make them work as a team because it pays off so well for everybody. We want people to own their problems and own their solutions. I talked a lot yesterday about getting things right down to the operations level, to the shop floor level, to the guys that are with the machines, maintain the machines, work the machines. Let's teach them how to do that very, very well. Then, of course, the magic secret, the secret that locks in the future success. We want to standardise and systematise. One best way. Not many good ways, one best way. And that best way, everybody in those teams, everybody in that business, everybody in production, maintenance and engineering and marketing are doing improvements on one best way. Please.
If you were going to define PEW in a single statement, would you say it optimizes asset management, it optimizes enterprise resource planning, or what would you say? How could
The
you
purpose is that it is to achieve maximum reliability at the least maintenance cost and maximum uptime. It's to optimise the resources required to maximise the operating profits of
So is
the
that
plant.
included within asset management or within enterprise resource planning? Is it a subdivision of it, or?
No, asset management, the physical asset management that Plant and Equipment Wellness is focusing on, is about working with your physical assets, your machines, your fixed equipment, to reduce their failures, to keep them working non-stop without any problems.
But also with the people involved.
Well, it's of course. I mean, people are the ones that are working with the equipment. In fact, we're finding human error is what's destroying most of our plant, most often. So yeah, it's the people are the key to the success. If people do not want to make the change, do not wish to adopt the necessary additional skills that are going to be required, are not willing to model financially decisions that they have to make. I just thought this sounds good today, and tomorrow this sounds good, and let's do that without doing the data take-up and analysis to understand what the right decision is. Then yeah, people will not achieve what's possible.
So when we say build a system-wide solution, that's the whole business.
Yeah,
It's a business
whole business,
solution.
whole life cycle.
So it's really a business management system.
In the end, and we'll see when we get to the upside down triangle, where we roll up from reducing the stress in parts right up to what the business actually does. That's the whole purpose. So we will have to ensure the business-wide requirements, whether you're engineering, whether you're sales and marketing, whether you're finance, whether you're maintenance. What do you have to do in your part of the business to ensure that you don't break the parts in your machines? If sales ask for twice the throughput that's possible in that plant, don't even ask. The production guys will just ramp up the speed. But as soon as I ramp up the speed, the stress multiplies by 3 times. And I'll break things 3 times as fast if I ramp the speed up.
So in a sense, it is a means of planning to manage all the resources of the enterprise.
It's an understanding of what effects you will have if you start playing with your options. Yeah, so it's meant to be a business-wide tool or a strategy to look at, gee, if I want to double the throughput, can I do it with this plant? If the reliability is very, very bad, yes, I could by winning back the reliability that I may have lost. If reliability is already very, very high and availability is already high, no, this plant cannot do it without breaking it.
We're not doing enterprise resource planning in the sense of planning production and sales and all these things.
No.
But it's a piece of it.
Yes, if production expect to get to run this machine at 125% its design capacity, now that machine will run 125% for a little bit of time. Then it breaks. So we repair it back at 125%, then it breaks.
So if you consider the assets as the equipment, the people involved, it is in a sense an asset management system.
In terms of physical assets and human resource assets that interact with the physical assets, yes. This is all focused on reliability of the plant, not on how to run your business, not on how to decide which engineer to put in which department. Nothing to do with that. But when you put engineers in departments, hey, think about teaming up this guy with the guys in the downstream on the shop floor, bring that knowledge that he's got. Now, one of my rules for engineers that work for me is they are not in their office more than half the time. Half the time, they're walking the plant, talking to guys, asking what the problem is. What more can I do to help you make this better for you? If my engineers are sitting in their chairs in the office, they're not doing the job. Their job is to be out there, make the plant work better, work with the guys. Engineers that sit on their bum in front of computers are a waste of time. If that's all they do, if it's analysis to find a way to improve the system, to reduce the risk, to remove the failure causes, hey, I'm on your side. But if I'm there just in front of a computer and it's not value adding, I won't shoot back out where you add value. As a mechanical engineer, you're the guy that knows what these machines are meant to do. You understand metallurgy, you understand the processes involved, you understand the interaction between the human being and the machine. Get out there and make it better. That's the sort of approach I'd expect from companies that adopt plant and equipment wellness. And because they're out there with more knowledge, teaching the guys better things, and the guys are telling him what's really happening in the machine, the team finds better answers than you and I will ever do sitting in the office. So yeah, this is a one-pager trying to get the big picture. And it is a big picture, it's a big effort, it's not easy. That's why I want to standardise and systematise. I want to have one best way, because I can't have 100 best ways. Can't be. Can be 100 ways, but only one of those is best. And I want to find the best and make it best and best and best and better again, to be world's best. And I want to have one technique, planet equipment wellness, only to get all the rest out. Yeah. All right, I'm going to be challenging people's concepts of what they think is okay. Because this is, at the moment, how most companies tackle their asset management decision making, how they decide what to do to maintain their assets. And this is what I learnt back in the 90s and what I thought was right. You know, as I say before, for 20 years I read the books, I went to the seminars, I followed the gurus, and 20 years after I say, why isn't my company better? Why aren't we up there with the world's best? You know, we've done everything we're meant to do. Then I realised that something terribly important is missing in what we've been taught at university, what we've been taught at school, what the MBA guys have been taught. They've missed something vital. So I go back to what I was taught and I say, look, this is what everybody says to do, and it sounds really good. I've got no troubles with what I see here. I just know there's something missing. There's a big white patch out here, big white patch all over the place that isn't full with what should be there. So what we do, we have a look at the process involved. There'll be drawings, P&IDs, process instrumentation diagrams, layout diagrams, assembly diagrams. So we've got the whole business blueprints on paper. And we begin saying, what are the critical units? What are the ones that are going to damage this business if they fail? So we obviously apply here equipment criticality. Equipment criticality determines which of the assets are the ones to be worried about. We want to know that. Now, what are the priority machines? So we can devote priority effort to the priority machines. It's very sensible, of course. Then we have to ask, well, what's the performance of the plant required to deliver the return on an investment originally intended by the project? So we have to decide how much availability must these critical units and plant produce or make available so we can make the product to then sell on to our clients. So we've got a target of availability and by implication a target of reliability as well, because reliability delivers availability, and if I haven't got reliability I'll never get the target of availability we expect. So yeah, and that then begins to look at how can availability be lost, what activities affect availability, what history of these machines. This particular machine design, the particular components in the machine, the materials used in that machine, what is the history of the problems these things give? So we can go back to the history of either our business or somebody else's businesses or the whole industry to pull out an understanding of the likely ways these things are going to fail. So there'll be failure modes, failure causes. We want to understand those from our various reliability databases in our company, in other companies, or around the world. This tells us what can make the units fail that will then cause availability to drop. So we want to understand where to focus our efforts. So select optimal tasks to match each mode of failure. So we do the activities that prevent the failures that will then limit availability. So in theory, this is looking really good. We're going to find why the machines fail, how they fail, and then put into place optimal tasks to prevent that failure. So this has all come from analysis of failures, analysis of the machinery, of the metallurgy and materials used. And of course we have condition monitoring techniques. Condition monitoring is to observe whether an item is still working at its required performance or the degradation curve has begun. So this is predictive maintenance. We observe how the machine's operating, looking for the first evidence of failure. And when we find that P point, we know that the curve has begun and it's just a matter of when we have the breakdown. So all this thinking, it's defendable, it's justifiable, it makes sense in an engineer's mind, makes sense in a manager's mind, has been done now for 20 years. This actually comes from an oil and gas company. This is their defined process, and these guys are seen as up there with the best. So out of all this analysis process and understanding of the impact on production and availability, we come up with strategies. RCM would be a technique that applies all this in a structured process, but it only gives us 5 options. Either we design the problem out, and get rid of the risk of the failure occurring, which to me is a smart thing to do, and you would do it if it's justifiably from a financial point of view. Condition-based monitoring, which of these machines, which of these failure modes do we have to watch for and make sure that as soon as they begin to appear, we do plant maintenance and corrective maintenance to address those. Time-based maintenance from these failure modes are some of those purely wear and tear. As I use this thing after so many hours or so much throughput, it gets tired. The brake pads on your car are classics. After so many kilometres, natural use, they're going to have to be replaced. The fuel filter, the oil filter, just after so many hours of use, they will be replaced. So either time actually should be usage. It could be throughput, could be flow rate, it could be hours of a clock. It just depends. But after a certain period of whatever happens goes by, you just do that job. Of course, on failure, breakdown maintenance may not be a bad choice if there's no impact from the breakdown. And then, of course, the final one is opportunity maintenance. Opportunity maintenance means if I'm down for a planned preventative job, is there anything else I can do at the same time? Instead of pulling the plant down again to do this second job, can I save that job to be done at the same time as other reasons the plant are down? So this might be a shutdown. You might have a condition-based job. So the condition monitoring has said, look, the bearing's got noisy, it's beginning to fail. We've got about a month before the failure. All right, in 1 week's time, we're going to shut that plant down to replace the bearing. I'm going to be down for 4 hours. Down for 4 hours. What else can I do in 4 hours with this outage? So I'll try and do more work in those 4 hours and not have to shut down the plant again to do other work that would have taken 4 hours as well. So we try and mix and match what we have to do that requires downtime in the downtime periods that are forced on us or we intentionally design into the process. So yeah, from strategies for production and profitability, we come down to what maintenance activities support that outcome. So in theory, the maintenance actually delivers the uptime the company needs. So I want to do this maintenance. This maintenance must be done because unless I do that, I can't get the availability. The plant breaks down for things we should have fixed or seen and did not do that. As it says here, we assemble a plan for the maintenance of each unit. Now, each unit, each asset, we apply the same strategy. This then requires the production windows we need to do the maintenance. Then this goes into the production plan at a regular basis, and everybody can see that there's going to be a certain period of time where we won't operate because we have to do the maintenance. That also ties up with what people and resources and equipment is required to meet that plan that will then deliver the uptime we want. It sounds great. You know, everything's there. All my answers are there. I know where it goes wrong. I know how to fix it. I'm ahead of the problem with my maintenance. I've got a plan to provide that availability. And still, machines and equipment continue to fail in companies. Even after all that, 10,000 hours of engineers' time, or 1,000 hours, or 100 hours, whatever it takes, still have breakdowns. Most companies still have breakdowns. And in fact, this says there should be no breakdowns because we're ahead of the problems. And we should be seeing it and repairing it before the breakdowns. Yet, that isn't what's happening. So we're still missing the target. This target of zero failure, we're still missing that target. I'm not saying zero maintenance, I'm saying zero failure. And we're after that. That's the intent, is to make sure that we have got a system where that outcome is the natural result, that we don't have failures. So the next few slides is about the aspect of business risk. Some of this I've covered before. I'll just touch on those and quickly pull it into an overall concept. We know that all our business, all our machines, all our work activities are series processes. So we are going to use the process maps of your business processes, the workflow diagrams of your operating procedures, and the assembly drawings of your equipment as the foundation documents for improving equipment reliability. They are used, respectively, to control variation in each business step, to control human error in each task, and to address and manage limitations of each part's materials of construction. So we're going to make sure that things don't go wrong. It's as simple as, I'm not going to be looking to repair things. I don't want to fix things. We want to make sure things don't go wrong. So there is nothing there to fix. We want to help people see what risks are out there and the effect of these risks so they can actually decide whether they want to have that risk or they want to reduce that risk. This particular slide is one from a quality systems handbook that's been around for a few years now. And I liked that because what it's saying is I can design the product quality, product outcome, business results, business outcomes that I want by putting in place, in the process of doing the business, the necessary methodologies and practices that deliver those outcomes. So if I want to have a quality product or a quality outcome, whether it's a service or a hard item that we sell, we have to look at the quality of the design. Can the design of the process that gives that output achieve that output? And what is the necessary standards of quality we must meet to guarantee this output? So independently of plant and equipment wellness, the very same requirements have been defined by these quality system gurus around the world. You can't get what you want out unless you build systems that can deliver it and that these systems continually meet the necessary standards that produce those outcomes. So all these outputs of a business have to be designed into it in the first place. And so plant and equipment wellness is understanding that I've got to begin at the very beginning and get it right from the start, because I can't fix it once it starts going wrong. Once it starts going wrong, I am forever repairing. And I'll be repairing and patching and gluing up and sticky taping and duct taping forevermore. Now this particular design of running a business is a very common way companies have built themselves. In this particular business, this company takes in raw materials into its receivable sections. These materials go to manufacturing. They then go on to assembly, for example. They're made up and go into dispatch, and then they eventually go to the customer. But the way they've set up their processes, they have an inspection point at the end of each step. Someone actually inspects the manufacturing, someone inspects the assembly. So they do all this work in here, then someone checks that all this work has actually been done. Now, there will be standards and procedures. The guys will work to some sort of design process, some sort of required SOP, standard operating procedure. But no one actually knows if anything they did is any good until someone ticks the box to say, yeah, you can now go to the next step. This is a very common design that companies fall into because that's what they were told to do 50 years ago by somebody in a management course. The Japanese or Toyota doesn't do it this way. Toyota does it a different way. My worry is here is if this manufacturing step requires 200 activities or 500 activities to produce the product. I've got 500 possibilities for something to go wrong from human error. If the materials here get through this checkpoint and are sort of borderline, they're close enough, close enough, you will push it through. Now this close enough gets a problem as it moves through the process. And we'll accept, things we accept that are close enough, in fact, in manufacturing give them serious headaches and cause downtime and waste and perhaps even rework and scrap. So this particular process, very commonly adopted by default in companies. What we want to do is challenge that and say, well, why are you letting so much activity go by before you check at the end it's actually built right? To me, it's like asking a mechanical fitter to strip down this machine with 500 parts, then rebuild the machine and put it back together again, and the only test I actually do is to press the start button at the end. And it's taken me 4 days to rebuild a 500-part machine. I have no idea if the thing's been built correctly until I press the button at the end. Now, if after 4 days I press the button and the vibration analyst guys tells me, you've got 2 noisy bearings here, 2 bearings that are a problem, am I going to go back and rebuild that machine after 4 days? I'm not. What we want to do is, as we are doing that activity, we want to have accuracy controlled procedures where the guy checks, uses the 3 T's, target, tolerance, test, and he's testing as simply as possible that everything is being done right. So I don't need an inspection at the end because the inspection's done as the work is being done. At the end of 4 days, that guy's going to tell me, fantastic, everything's right. Look, I've gone through the procedure, been watching every single task, I've done my tests, there's a tick and a check, I've got a measurement here, measurements within the tolerance, that's okay. Tick, 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 and here's my entire procedure for doing this 4-day job, and I know it's right. Yes, start the machine up because it'll work just fine, thank you. And that's how we want to build our processes in plant and equipment wellness. Continual feedback throughout the actual activity. No more inspection in between the major parts of the process. It is right because it's built right. It is assembled right because that's the way we build things here. We assemble things right every single time because we are running an electrically controlled process, and that requires the 3 T's. And that third T proves to me it is right. And so this particular way is the way to get maximum payback on our resources. Now, it may take a bit more time to do a number of extra tests, but there's no rework, there's no waste, there's no loss of warranty claims. And this is the way that the good companies build their business, that we have systematic ways, standardised ways to guarantee quality all the time, everywhere. So again, a one slide idea of what we're trying to get across here. We want to have a system of doing work, of running a business, of doing a production process that the inputs are as required. Now, when these things come in, when the raw material comes in, it is to spec, it is well within the boundary. And my material comes in, there's my specs, and the material distribution is well within the boundaries. So I know I've got good quality stuff to start with. It goes into processes where this becomes the output of the steps in the process. And each step, as I work through and manufacture what I'm manufacturing, we're checking that what we're doing, the distribution of the results from the tests, is within the boundary that gives us the results we're after. So we're proving all the way along through measurement and data collection and presentation of that data that we are on track. No problems, perfectly fine, going to be great. So the process is in control, the inputs are in control, the process is in control. If the inputs are in specification and the process is in control, the output is exactly what you want. So I don't have to measure the output because the output is exactly what I want because the process is in control and so is the inputs. It must naturally that the output too will come this way. Here, I check the output and hope the output is within specs. But if the output comes out like that, then this is all waste and scrap, all rework and loss. So yeah, if I measure after the output is made and the output is rubbish, then I've got to throw it away and start again. But if I measure that the inputs are correct, that the process is correct, then the outputs must be correct automatically. So I want to build a way of running a business where this is how we do it. Inputs are in control and capable, and the process is in control and capable. Then, of course, everything done by that process must be correct. So that's why we want to standardise. That's why it's vital to have one best way. Of course, the first model, the first way we build this process won't be the best way. It's going to be the beginnings of continually improving towards the best way. So I expect to be changing my process, changing my way of doing things, challenging guys to come up with better answers all the time. Because the one best way is out there. We're never going to get there. That's the idea of excellence. We're going to strive for excellence, find a better and better way. But only one way. I want to have one way that ensures no matter what I do, everything always comes out with top quality that can be sold and that people want to buy from us. So we're going to adopt the best practices as quickly as possible because I don't want to wait 10 years to realise, you know what, lean and the right way of doing lean actually pays off. You know, reliability and precision maintenance and the fact that I don't yet know how to do it, well, I better start learning that very quickly because precision maintenance drives reliability. I can't wait 10 years to bring in precision maintenance. I've got to get on with this now. So we want to help companies adopt and apply best practice, because best practice is better than what we're doing. Best practice is best because it's far ahead of the rest. I want to be doing the best processes, so I've got to bring in the best practices as soon as possible. So my process is now the best process. And of course, it needs to be a culture in the company. I want to make it best practice, an organisation-wide habit. Habit, a culture, a norm, the values, our beliefs. Habits are what we believe. We do things because we believe it's okay to do that. We value what those beliefs bring us. So best practice becomes our habits. So I've got the right processes, I've got the right inputs, I must have the right outputs. So we're going to have standards for equipment, for operating practices, for engineering across the life cycle, for maintenance, and for the life cycle business as well. And we're going to standardise and we're going to have standards. We're going to standardise across the business for equipment, operations, engineering, maintenance, and business systems. We want these parts of the business to have standards that produce this outcome, and to use that all the time. That's how we get our one best way. We have the one best way because we standardise on doing things only one way. If I've got 100 engineers in my business, there isn't 100 ways to do a particular job on a machine. There's one best way. I want my guys to find that one best way and then improve that to become even better again. We're only playing this game. It's the whole story of Plant and Equipment Wellness is to drive the business to do the right things that produce the right outcomes. So if I'm already delivering good output, where it should be, then that's great. Let's just do that smarter and faster and cheaper and more optimal. But if I'm finding that my output is not where it needs to be, that's okay as well. We saw yesterday when we had the crosshair game, that output, I needed 10 out of 10 in that circle. You couldn't get 10 out of 10 because the process I used was unable to deliver the requirements of the particular client. So I've got a process that isn't achieving the outcomes I need. So what we said is change the process. Come up with 4 solutions that were far better processes: the tube, the cylinder, the cone, the sliding rod. So we can move our processes towards what we want until we're eventually sitting right over this area of excellence. And now what we do always produces the right results because that's how we do it. That's the habit we've got in the company. That's the culture of the company. The company's culture is excellence and striving to become better all the time. And as we know, Mr. Deming said, your system is perfectly designed to give you the results that you get. So what you're getting today is because that's the processes you chose to use in your business. And that's the natural outcome of that decision. And it will always be that way. And it's unchangeable because it is designed into the habits of your people and the habits the way you run the company. Standardization and making that systematic, it's going to come down to documentation. We're going to have to write down, script exactly what needs to be done to achieve this outcome. I cannot leave people decide, how do I achieve these great quality results? So I'll do it this way today, and I had a chat with Fred yesterday, I'll do it this way tomorrow, and next week a new manager comes in and says, I better follow that manager's way, and because he's a manager, he knows what he's doing. That's not going to get us anywhere. That's not standardisation, that isn't systematic. I want to have one best way. So I'm going to have to write documentation down to the detail of how to connect terminals on electric motors if I need to. This connector goes there. It doesn't go over the top or underneath. This is the only one right way for the job. This document goes out with every single time electric motor terminal has to be connected, and every electrician in the place knows this is the only way this job is done in this company. Oh yeah, but the other job I was taught to do it, forget about it. Don't care about the other job. If I bring in the other job's solutions, then this process outcome that I had designed to achieve, if I bring someone else's ideas in that I haven't yet tested, that will naturally produce outliers, naturally have outliers. And those outliers will be breakdowns and waste and loss. So I don't want to have guys coming in with bright ideas until I test and prove those ideas. So yeah, let's not experiment with what we don't know about. Now, I'm not against bright ideas. In fact, I'm challenging people to come up with good ideas, with better ideas. When there are good ideas, we're going to put them into a trial situation, a test, an experiment to prove they are better. And once they are better, if those ideas give a distribution like that, then I'm going to take that idea into my one best way. But I won't do that until I'm sure that distribution of outputs is better than my current way of doing things. Very scientific approach. Scientific management, scientific engineering, scientific maintenance, scientific production. Data-based decision making. And if there's no data, I'm going to say, hold it guys, let's go back and collect the data first. Oh, that'll take us 2 years. Let's go back and collect the data first. Can we go to someone else that's been doing this already? Let's go to their place and see how close they are in what they're doing to what we're doing. Can we transfer that knowledge to us with certainty? There's ways to do this. None of this is new, as the point is to make it a habit, to make it a cultural way of running the business. Now, if lean manufacturing and some of the ideas in lean give us better results, I am going to jump at that. I'm going to force it into place. I'm going to try it and prove it works and then make it the rule, the new one best way. I don't care where the good ideas come from. Ideas don't care who has them. But if we have a good idea that gives us a better outcome, why the hell are we waiting? Let's get on with it. Quality management systems, a lot of work done in this area here. ISO 9001 is an example. This is actually from some of the documentation in various books in ISO 9001. There are particular ways to have quality management systems work. We're not going to reinvent the world here and reinvent the wheel. We're going to use things and processes that work. Now, there's a planning system required, there's a control system required, there's an improvement process required, and there's an assurance process required. And we're going to combine all those into plant and equipment wellness also. You know? The things that work already in companies, we're going to stick with those. There's nothing wrong with that. But we want to have it in a regimented way. A quality management system is what it says. It's a system to deliver the quality in a managed way. Controlled and designed and intended procedures and practices and methods and habits and culture. So we're just going to do what the words say. Systematise the quality outcome in a properly managed way. Components, of course, I've discussed this now many times. Our machines are long chains of parts, and every single part is a link, and any one of those links fail, and that chain fails.
Would it be correct to say that ACE3T is a quality management system that would meet all the requirements of ISO or anybody?
It would eat ISO alive. ACE3T is well above what 9001 even imagines. The 3 T's is the secret. 3 T's define the quality. Now, if we want this quality outcome, what the 3 T's do is they say, okay, here's my target. My target is that. The tolerance, because there's variation, I have to allow for that variation. I want the variation to be within my standards. So that's my standard. If that's my tram lines, as I mentioned in that slide yesterday, that's my standard. I want the variation to be within that standard. So that's the tolerance. I've got my second T down here.
What if somebody said, my management is forcing us to get ISO 9001. Can I use ACE3T to meet the requirements of that?
ISO 9001 is a lovely framework. You look at 9001 and it requires you to structure your documentation system in a manageable framework. So I would use 9001 as the framework to build 3 T's, ACE3T into it.
So when the auditor comes in and looks at it, if he doesn't know anything about ACE3T, he'd say, okay, I'll accept that as...
It would comply. In fact, we would make sure that ACE3T is well within the compliance of 9001. The secret is that 3rd T. That 9001 does not ask you to do anything. It just says, this is what your company's meant to achieve. It's 9001, you look at the clauses, it tells you what to do. It never tells you how to do it. ACE3T tells you how. ACE3 tells you how to do it, how perfectly you must be to achieve the outputs you want. Guarantee repeatable 100% of the time. And that third T is a check to prove we are, in fact, repeating this 100% of the time. And if I'm not, then my process needs to be adjusted. So yeah, 9001 tell you what? Tell you what to do. And of course, 100 different companies decide 100 different ways what they want to do in the same industry. ACE3T says no. This is how you achieve what you must do. And you will do this one only way. The best way. The one best way.
This is for companies that are serious. There are many companies that want the sticker, the ISO sticker, because it is required by some of their customers, but they really have no interest whatsoever in improving quality. So this would not be for those companies. You have to be interested in improving quality.
Got the wrong mindset, you will never get there. You'll be shipping your jobs off to China. That's what you're going to do.
Our job would be to prove to them why they need to change.
Yeah. And the money they're leaving behind. I'm sure across the world we're leaving trillions of dollars falling off the side of tables. I'm sure it's there. So yes, the secret is to make all this a cultural habit. You know, we're not going to argue about ACE3Ts. ACE3Ts will give you this distribution control without question. But the thing is to then make that the way we always work. That's why it's important to have one only way. I can't have 100 best ways. There's only one best way. So yes, we know that machines are components in series, which means that if any one of those break, the business is down. We use the flow diagrams to make it very clear to people why that inner race is important to the business. Why lubrication is vitally important to machinery. Why doing the lock nut up properly and in fact putting a lock nut tab there. To me, there should be a lock nut tab in there as well. This makes it very clear that any of these go wrong. The smallest little bearing worth half a cent bearing rolling element fail, my business is down for half a cent. And this is what people have to realise. This particular slide here is a planning process for maintenance work, and a lot of companies will have flow diagrams like this. They are not much use to us in this fashion. What we have to do is interpret those flow diagrams into reliability block diagrams, convert that previous flow chart into a series arrangement. Because tucked away in here, if we follow these arrows through the process, is in fact these activities. Once we're in this situation, I can say to people, well look, if I order the wrong parts, does that matter to your machinery? If the wrong parts come in on a breakdown job or a corrective work job, is that a big issue? Now, if I buy the wrong parts in and the machine is now down for 2 more days waiting for the right parts, I think it's probably going to be pretty important. So now I can talk to managers and say, which of these steps in the maintenance planning process and maintenance machinery repair process don't you care about being right? Oh, I don't care about costing jobs. I don't care if the guys don't put a single second into costing the price of a maintenance job. In that case, take it out. Don't bother costing jobs. But if it's important to know if a job's going to cost $10,000 or going to cost $50,000 before you make the decision when to do that job, then you better leave that particular item in there. So we can challenge people's thinking, challenge the company design, the company processes selected, once we have this degree of understanding of how these things interact. Here's an example of a maintenance job, and I guess I'm dealing with machinery because most companies' physical assets are machines of some type. This particular job was to replace the bearing inside the pillar block here, or plumber block as some people call them. This is a job plan, 16-step job plan to to do the job. And this is very commonly done in companies. The maintenance planner or the supervisor in charge of the crew will put together the milestone tasks. These 16 points are milestone tasks. These are the output requirements of working through to do this job. There's something wrong with this particular approach. There's no idea of how to do that work. Now, this is what to do, but no idea of how to do it. So what I've then done, if I just hand that piece of paper to my technicians, and I have 100 technicians that can do that job, and I pick any one of those 100, I have created a distribution of outputs. Unknown what they will be because it doesn't say anything more than this one page. So my 100 guys, each one goes out and they will do each of those in their own way, to their own time, to their own particular concerns and risks and worries. And if last night was a night on the booze, today won't be a good day at work. And of course, the distribution then, that means that guy's day is going to be an absolute horrible outcome for the company. Most companies do it this way. They use their trained technicians to say, well, here's the milestones you've got to achieve, off you go. That automatically produces huge variability because it doesn't tell them how to control that. So what's missing here is how to do that job the one best way. Now I've taken those 16 steps into a flow diagram. In this particular way here, I can begin to see the interaction and the effect each milestone task has. Now, if I get that wrong, then that machine will fail earlier, sometime in the future. Now, if that's not done right, or I leave it out, or it's very clear now. That's a series process. At the end here is meant to be a long-lived machine with 5 or 6 or 10 years trouble-free operation. And I don't do that well, or I don't do this well, or I don't do any of them well. I'm never going to get my 5 or 6 years. So to help my people, to help my company, and to do the right thing, I should also tell them how to go about getting 5 or 6 years trouble-free operation out of your repair job. But that's not given to them. No, they're only given that. That's all they're given. The rest they work out for themselves. Now we overcome that problem with one more step. We actually write job procedures. So job plans do not deliver job quality. For that, you need detailed job procedures and proof tests throughout the rebuild activities. So this 16-step job plan, when we turn it into a procedure, let me show you what happens. Okay, that's that conveyor pulley there. This is a bit of an intro on some information in the workbook. I then go into actually the details of the job itself. I include all the parts and materials and tools they need. I leave that particular diagram in there. I don't expect planners to convert their job plans into a flow chart. I leave that there in the example to make the point that all of these are important. There isn't one here that I can afford to do wrong and expect to get 5 to 10 years trouble-free operation out of my machine. But that's only the job plan. Now I'm going to do the job procedure. So I start at task 1, which is done by the technician. It involves preparing for the job to make the area safe and clean and trouble-free. And I work my way through this entire job. Remember, those 16 milestone tasks all have to be achieved. We just don't know how they're going to do it. Now, the guy will do it the way he thinks he's okay to do it, which is what he learnt in the last 20 years off 15 other guys. That's what's going to go through his head. But it isn't necessarily the one best way. It might be the one best way. I mean, luck can be in our favour that day, but it may not be. So we take that job plan and I start doing a job procedure. So bring this a little bit bigger. So that, the guy will have to measure the shafts, record measurements, check the shaft is actually round and cylindrical, sufficient for the bearing. He's going to have to do that at different parts of the shaft, both ends of that shaft where the pulleys are. You're going to check the parts of the correct parts. Oh, there's calculations required to get the interference, to get the clearance right in the bearing. He has to do a mathematical calculation to make sure that he sets up that clearance with feeler gauges. So as soon as he sees a calculation there, we know from human error rate tables, some guys are going to miscalculate. Guaranteed to happen. So how do I help my guys get it right is an issue that a planner will have to do. You know, my 16-step job plan said nothing about the calculation required to set the clearance. Gee, I hope the guy knows what he's doing, can do the calculations, understands mathematics well enough to do that job properly, because I never told him what he has to do. Oh, he's years of experience, the 30-year man, he'll know what to do. Well, I hope he does, because I don't know what to do. There'll be tables to select clearance values from, depending upon the size of the bearing, different clearance between the internal components. Gee, I hope he gets the right line. I mean, there's, hope he picks the, gosh, I won't be there. Nobody else but this guy will be there. I hope he gets it right. There is, he's going to have to check the clearance. It has to be spot on because I want to get 5 to 10 years trouble-free operation. And we go on down. Oh, look, another measurement. This is for the base plates. More measurements. Oh, this is for driving up the taper sleeve on the shaft to get it in the right position so that when the bearing finally is bolted into place, the clearance comes right. Hope he knows what he's doing because I don't know how to do it. I hope he does. And on we go. This is the detail. These 16 steps on his job plan, the guy has to do all this. To get to the end of the 16 steps, he has to do all this and get every single thing right. Out of his memory. Out of his memory. Base plates, alignment, flatness, installation, positioning, greasing. Gee, is it even the right grease? I didn't say on my job plan about getting the right grease. I hope he knows what grease to use. It didn't say what to do. Just, he knows what to do. I don't know. I hope he does. We go on down. Oh, look, I've got to assemble it properly, install it properly. I'll get the alignment of the shaft so I don't damage the seals. Because if those seals are damaged, all my rubbish goes in there and I won't get 5 or 10 years trouble-free. I'll get full of water and it'll be down again in 3 months. 75 tasks to do those 16 milestones. Do you think any human being in the world can go through 75 tasks out of their memory? And yet this is what we asked him to do. We gave him a piece of paper. Please do this job. And of course he goes. That's his job. I will do that job. I could never get it right, but you give that to me and say, Mike, off you go. I'll do the best I can. I'm an engineer, mechanical engineer. I'll have a damn good idea of what I'm meant to do, how accurate it has to be, how perfect it has to be to ensure that the outcomes are not like this, but like that. I need to be here all the time. I've given the guy a process that automatically guarantees ongoing failures because it doesn't tell me how to do it. How do I control it to be there all the time? If I can do that, then this disappears. I can stop this rubbish going on, but I've got to write the documentation. I've got to write this. Without that, nobody can win. Oops, let me get this right. Get to it first, there we go. So yes, procedures, absolutely vital, because that's the how. That's the how to get the distribution right every single time. And without the how, I just hope it's my lucky day. Now I'm running on luck. My whole business is running on luck. Go find good. And what they say these days, of course, is the people make the difference. Get the right people for the job. Of course, you get competent experts, you get brilliant guys, 1 in 1,000 guy that gets it right every time. How are you going to find that guy? How are you going to keep that guy? Well, I've got to build a business process that doesn't matter who the guy is. Just follow the rules, Fred. Larry, just follow the rules, mate. Here it is. You don't know how to do it? I'll take you to school and we'll get you to do some bearing installation training. And we'll make sure you're good enough to come back to work and do this job properly. I can build a company to do all that. Why would I bother? Well, It all depends what that costs. Because that's money I'm throwing away because I haven't got a process to guarantee the quality that gives me the reliability I need. For 20 years, I just did the same thing as everybody else. All my life, I was taught, I was trained. I would have been, that's how I did it. 20, 50, 100 years this is the rubbish been given for 100 years. You wonder why we have problems. You've created it. You've guaranteed huge variation forevermore. How do you stop that? Well, do it right. Please, Mr. Manager, tell me what right is. Tell me how to get it right. Teach me how to do it right, and I will do it right for you. But the manager wouldn't even know what to do. Supervisor doesn't know any better. Supervisor gave this document to his people. The planner wrote that out, thought it was enough. The manager ticked it off. In fact, the planner got an award that month for being the best employee. What a load of rubbish. This is the world we've got. We've got this world with massive distribution. Everybody knows it's wrong, but can't work out what to do. Well, what is the right thing to do? Write it down. Create the processes where this always happens. It isn't hard. It takes a bit of time, takes a bit of investment, takes a bit of effort. But gee, it's not hard. It just takes time and effort. Piece of cake. But you've got to see it. The guy's out there, he's busy. Takes him 2 days. He's good. He's always working, busy, head down, bum up. But it's pointless. Pointless. Now, I've got to be fair. Within this big distribution, there is this area here. Sometimes you will get it right, even with this way of doing things. But gee, I hope it's my lucky day, because I've got no other way except pure luck to have that outcome. And so that's why, back when I was 50, working for the company I was working for, I got the books, threw them away. This isn't working. Now that first slide, the earlier slide where we've got this model of how to come up with maintenance strategies and activities to guarantee availability, I did all that. Never worked. The company that uses this stuff, they're having breakdowns all the time. They lose millions of dollars each week from breakdowns, following that strategy. I'm fed up. I'm fed up. Had a gutful. Don't want to go there anymore. It's not working. Yet I know companies have gone from dogs to world class. How do they do it? Procedures. They wrote exactly what the right thing to do is. And then the guys followed it.
Did the management of your company, when you realized it wasn't working, did any of them ever think it wasn't working? Or were they just saying, you're doing a great job, this is just the cost of doing business?
As long as they saw I was busy, they were happy. The fact that what I was doing achieved no results that were worthwhile, they thought it was okay. I'm working on improving things. I didn't know how to do that, but I was working on it. And in the end, they were making profits. They were making money.
How do you overcome that, assuming they're typical management?
Well, this sort of stuff helps. Paint a very clear picture of what the world really is.
You have to do that because the losses that are outside of the tolerances are built into their annual business plan.
Yep.
That's built into profitability.
Yeah.
Even with the losses, they're showing profitability because it's built into their plan. So it has to get shown to them.
It's an unknown fact.
It has to be proven.
Yes, and that's Planet Equipment Wellness's purpose. That's why everything has to be financially based, as we would expect ourselves. So I'm not blaming anybody, but everybody's missed the point. Not everybody, I've got to be fair to this. Toyota has not missed the point. GE hasn't missed the point. DuPont hasn't missed the point. Other companies understand, but many of them don't know what to do to get there.
Yeah, that's my experience. My experience is most companies actually kind of see a little light at the end of the tunnel. They kind of see this. They kind of understand. They kind of know that they don't know how to get there. And the problem is they're really reluctant to spend money to get this without understanding the correlation.
True.
And I haven't personally been able, in most cases, to bring the correlation to them.
Yeah.
And even when I've been able to get them to take a leap of faith, I haven't been well enough prepared to get
Continue with it.
to get all the.
Yeah. And it shouldn't be up to us, the consultants. So we're here to assist. The work's got to be done by them. That procedure for that bearing replacement, that took me 4 days. Mechanical engineer, 4 days. I've got the 3 T's in here, good, better, best, so I'm looking for what is the best world-class result. I want to know that because I'd love to get that every single time. In fact, I'm going to build my process eventually to drive everybody to this. Eventually, in time, I'm going to build the process with my 3 T's because the target is, world best is certainly there. I'm going to have a process where, in the end, I will create an even tighter outcome. But not there yet. Today's too early for your company to be that good. You can't be that good yet. You've got to earn that right. But I'm going to build into my processes where you've got to go. And I'm going to help you guys move down that path.
Now, if a guy if a technician has been doing it the old way, and he gets this document, and he walks out in the plant where no one is watching, he might just,
That's why he's going to have that's why we have the test. You've got to measure. We're going to make sure that he measures things, records things. And if the document comes back to me as a blank sheet of paper, I'm going to say, come to my office. What's happening? Why are you doing this? What are you thinking that it's okay not to follow the rules? That's the rules. You've got one more chance. Oh, sorry, I don't know how to do it. Why didn't you say that first? I could have got Fred to do that job, not you. Why didn't you tell me that? Okay, your training plan for the next 2 months is to learn how to do this properly. There are answers. There's nothing difficult. There are answers. The hard part is being honest and being able to just tell people the truth in a fair way, fair but firm. That's a good way to tackle it, fair but firm. So yes, this is the how. The what. ISO 9001 gives you what's all over the place. Every company does their own what. No one ever writes their own how. So PW, how is the vital answer. And that how won't be the best way to start with. It'll be better than what we got. Then guys, Fred, Larry, Barry, John, find a better way. I want you to show me a better way. It's out there, got to be out there. 75 steps, all of which can be made better. You try these, you tell me what's a better way. And I'm going to write that in. We're going to prove it. Once I've proven it, it's in.